Hello, good morning, good afternoon, good evening, wherever you might be. My name is Sean and I'm delighted you're joining us for today's ESPC community webinar. This webinar is part of the Microsoft Fabric Week, proudly sponsored by ActRees. Today I'm joined by Rata Eskins, MVP, who will present Let Your Fabric Work, load testing large amounts of data. We love hearing you guys have to say, so remember to join in the conversation about today's webinar and more on X. Our handle is at ESPC_community and our hashtag is hashtag ESPC25. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which is updates the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointeurope.com, and clicking Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar, A Day in the Life of an Accidental Fabric Administrator, with Nikki, MVP. This webinar will take place Tuesday, May 27th at 1 p.m. CEST. For more information on this webinar, please check out www.sharepointeurope.com/register for webinars. Looking to expand your Microsoft Fabric skills? Join us in Vienna 15th to 18th of September for the European Microsoft Fabric Community Conference. Experience 3 keynotes, 10 full-day tutorials, and over 130 plus expert-led sessions covering data engineering, real-time analytics, business intelligence, and data governance, and more. Sessions are delivered by Microsoft experts, community leaders, and Microsoft corporate speakers. Enjoy hands-on workshops, valuable networking, and memorable social events. Scan the QR code to get your ticket and use code FABRICWEEK150 for €150 off the current deal. FabCon Europe tutorials are here. We're excited to launch a series of hands-on tutorials focused on the latest innovations and practical applications of Microsoft Fabric. Topics include Microsoft Purview, Power BI, data warehousing, Fabric data agents, SQL databases, and more. Learn directly from experts and gain real-world skills you can immediately apply. Use code FABRICWEEK50 to get €150 off the current deal. Limited time offer only. As always, if you have any questions at any stage, feel free to type them in the questions box and Retso will get to them during the webinar. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it's available. And now I'm going to pass you over to today's webinar presenter, Retsa. Hello, Retsa. Thanks for joining us today.
Thank you for having me. So let me show my screen. And if everything is working nicely, you should be able to at least see the title, which means we can get going. There's a lot of noise. This session is about letting your fabric work, load testing a lot of data. So let's start with some concepts, because what is a large amount of data? What is a lot of data? And to start with that question, it's different for everyone. So let's take an example. Suppose you're a small corner shop in the outskirts of a medium city, say about 50,000 people living there, and you're getting 100, 150 customers every day. That can be a large amount because you're a small shop. Collecting all the cash receipts and transferring every line on the receipt into your accounting system and ordering system, it will be tedious. Ruin a perfectly nice summer evening. Maybe it's about 2-3 megabytes of data, something like that. Now, if you're running a store in the city center, you might get 1,000 customers every day, and they will get some items from your store. And by then, I do hope you've got some automation for your receipts, because you don't want to do that by hand. And again, you've got more and more data. And suppose business is going really well and you're going to multiple locations, multiple cities, and all of a sudden you get 10, 20, 30,000 people in your shops. Again, more and more and more and more data. But this still isn't a fixed definition of what a lot of data is, or what a large amount of data is. So I'm going to set the definition for this specific session, which means that for me at this point in time, this is a large amount of data and a significant amount of rows, which means around 5 billion rows. It's somewhere around that area, and 500 gigabytes of data. Is it a lot? Well, for me and my daily work, it is. Maybe for you, it's like, yeah, that's our delta load halfway through the day. I don't know, but it's a lot of information for this session. So next to up to the next concept is like, how do you do load testing, and what is load testing? What does it tell us? I mean, processing 5, 6, 7 billion rows is a fun exercise, but what do you get from it? And will the results transfer to your own world? Well, that question alone is one I can't answer for you. I can't walk over to you, get into your skin and brain and transfer the session into your world and your way of working, and maybe that's for the best as well. But let me take you back a little bit to May 2023 when Fabric dropped at Microsoft Build. There was a lot of stuff going on, social media went wild, and I thought, well, let's get into it. So first of all, I activated the trial license, where it does help that I'm the global admin of the company I'm working for, and I started to create some resources. And like most people, the first thing I did was taking Microsoft Learn content to get a feel of all the buttons and all the stuff, and it runs on the AdventureWorks database. And that's all fun and games, and it works really well, but this is kind of sort of the corner shop I was starting out with. For a load test perspective, it's like putting a pigeon on a mooring cable and telling it, yeah, it's a strong cable. It's not in balance. So in my daily line of work, I work with larger data sets. So I had to find a data set that matches that. And let's just say using customer data is frowned upon. So I had to find another route with the same or maybe even larger amounts of data. And after I found that, I had to measure the results and find out what it was doing for us. So that's about what this session will be about. Well, before I continue, a little bit about myself. My name is Reitze Eskens. I'm working for Axians in the Netherlands, where I'm mostly active as a data engineer, an Azure architect, and everything else in between. I'm a Microsoft certified trainer, so I can teach classes. And as of January last year, I'm on Microsoft MVP as well, which means I get in contact with the Microsoft program team a lot about things I run into. Now, on the left of this slide, you can see a QR code, which will lead you to my GitHub repository, where you can find all kinds of resources, including this presentation, where you can scroll through it, so you don't have to take screenshots during this session, but you can review them at your own pace. If you want to get into contact with me, on the right on this slide, you can see a few ways to get in touch with me. Use any of those you like. I'm happy to answer questions or dig a little bit deeper. And as some people say, I've been doing unspeakable things to F2SQ since 2023 for science. So this will be mostly about the F2 compared to the F64. So I just talked a little bit about concepts, and I need to go to monitoring to find out what's happening. And how do you do that? Well, I'm coming from a SQL world. And in my SQL world, what I'm doing when I want to measure performance, I'm using statistics, time, and I/O to measure what's going on. I'm looking at the execution plans, and I'm monitoring memory, disk, and CPU. Welcome to Microsoft Fabric, where you can measure time looking at the execution time of certain items. That's about it. I/O you can't measure. Execution plans, well, you could dig into the Spark execution stuff that will reside somewhere in the background, which is hard to interpret, especially if you're coming from a SQL world. But if you're using pipelines, for instance, there's nothing. It's like go and you'll wait until it's done. Monitoring memory, disk, and CPU, that's where things start to differ, because you can monitor some of this stuff. But you're going to learn a new tool. It's called the Fabric Capacity Metrics app. I'll show you a little bit or a lot more about that one later in this session. But long story short, it will show you the used capacity units, but it's a default design, no customization that you can do on this one. But this tool not only shows you stuff, you need to learn some stuff. You need to learn about how capacity units work. And you really need to learn about this to prevent going down a lot of horrible pitfalls I've documented on my blog. So we're going to learn new metrics. So we're going to talk about capacity units. So the basics is this. 1 second of work is one capacity unit. A capacity unit essentially is compute time, memory, and I/O all smashed together into a capacity unit. If you're coming from the SQL world, you can kind of sort of compare it with the database transaction units, the DTUs that are used on the standard and premium databases. But 1 second of work is one capacity unit. If you're using an F2 capacity, this equals to 2 capacity units per second. Capacity units are evaluated in blocks of 30 seconds, which means if you're using an F2, it's 2 times 30, it's 60 capacity units. This is a number you need to keep in the back of your head because I'm going to come back to this one later. If you're using an F64, it's 64 times 30 seconds is 920 capacity units. So these numbers are quite essential to keep in the back of your mind. But I was talking about the Fabric Capacity Metrics app. And when you open this thing, it will show you a lot of graphs, and I'm going to talk you quickly through a number of them because they're essential when you're doing load testing to find out what's happening. So the first one is the multi-metric ribbon chart. And I'm guessing Microsoft created this name if only to make non-English speaker stumble upon this line. What you can see here is a kind of sort of overview from a few items you can use within Fabric and their relative use to each other. Because when you're looking at it, on the left side, there's no y-axis. It doesn't show you the numbers. So this one on its own won't give you all that much information. It'll give you an overview of what's happening, but it's not telling me I'm overusing or underusing the capacity. When I start hovering over it, I can see which item has contributed to this bar and with how many capacity units. 4 places after the comma. When you've just seen the basic calculation, it's like 1924 30 seconds, which is a rounded number, and now all of a sudden I've got stuff behind the comma. Don't get into that. Nobody's really paying attention to that one. It's the numbers before the comma. So you can see 495,720 capacity units used for this day. So apart from calculating capacity units in blocks of 30 seconds, you also need to expand that to how many capacity units are available during 24 hours and how does it spread out. It's the more you get into it, the more agonizing for your brain it will get. But this will give you some information, but in the end, this is not everything you need. So when you go to the right on the top right-hand side of the Capacity Metrics app, you'll see this screen, which will tell you capacity utilization and throttling. This is where stuff gets interesting because you can see kind of sort of a timeline appearing. There's something happening here as well. If you look closely, you can see there are gaps in the lines. I'll get back to that in a few moments. Thing is, now you can see the load during the day. So you can see there's a peak somewhere, and then it's slowing down again, and it's coming up again and slowing down again. This will give you more information on what will happen. Now you can see utilization. You can also see throttling and overages. So the utilization and throttling works like this. If you're bursting your capacity for less than 10 minutes, you won't get throttled. Everything will keep working, and the overusage you've got, because if you've got an F2, you can use up to kind of sort of F8, F16 capacity for a short period of time. If you do it really short, you won't notice a lot. But if you're going over 10 minutes, but less than 60 minutes, the interactive jobs, stuff people are interacting with, they get throttled. It doesn't mean they get rejected. It's just moving more slowly. If you're going wild, like I've done in my testing, interactive jobs will be rejected. So end users will see an error message. And if you're using more than 24 hours extra capacity based on what you've bought, yeah, you get rejected, stuff won't get executed, and it will be messy. I've been there. And this bursting and smoothing process is how Microsoft calls this. It works, but it has its pitfalls because at some point you can seriously overload your capacity. My personal best so far is 54,000%, and it took about 3 days for the capacity to recover and start functioning normally again. So you need to pay close attention to what's happening here. These bars offer drill-through options where you can get to the details. Now, as I mentioned, there are some gaps in this graph. So what I found out when I was joining a session from Benny de Jager, the Belgian guy who works for Microsoft and shares a lot of insights, he told me don't slide. So when you're sliding, you're doing like this, just getting a small portion of the data, and you see all kinds of gaps. The thing is, these gaps appear because Power BI has a maximum number of data points it can display in a graph. If you use another method where you're just filtering data, and I should have called it filtering instead of zooming, you can see that all of a sudden you won't hit that maximum of 40,000 data points, and all of a sudden your graphs get filled in nicely and you can see more details. So you get more information. There's something else happening. When you're going to the time point details, you can see that I filtered from 11:17:30 to 11:18:0. So a block of 30 seconds. But if you look closely on the right-hand side, you can see that I've got processes starting at 11:14, 11:13, 11:12. There's all kinds of other stuff happening, which shouldn't show up in this graph in this time point detail because I want to focus on 11:17 to 11:18, not 11:14. So when you change this table, there are properties there where you can add columns. And in this case, you can add the column smoothing start and smoothing end. And all of a sudden, you can see that these processes that I was thinking, what are they doing there? They're being smoothed out. So what Microsoft is doing is not using all the capacity at the point in time it's requested, but it's smoothing it all out during a period of somewhere around 24 hours. Which means your capacity can keep churning through all the work it should be doing, and you're paying it back slowly. There are positives and negatives about it. Sometimes it can bite you, sometimes it can really help you. But again, this is something you need to dig into the documentation and really get a grip of to prevent nasty surprises. So when you're talking about large amounts of data, it's all a matter of perspective. Microsoft Fabric allows you to learn a lot of new skills. I didn't get into what Microsoft Fabric is, assuming you all know what it is. But if you're coming from SQL, for instance, you can learn PySpark, which is also a new skill. But measuring Fabric capacity usage is one of them, and it's an important one. Sean, any questions I need to answer, or can I continue?
No, you can continue. Just
all right. Excellent.
Yeah, all good.
So from monitoring to stuff to creating the data, because I needed to create data. What I did was use the TPCH dataset. When you start browsing online, you won't be able to find that dataset, but you need to create it for yourself. It's a little bit funky to get working. You need to tinker a little bit with some compilers to get the executable running on your own machine. And then you can use this command line dbgen.exe with a few flags to create your dataset. It's in the end not the hardest thing. There are a few links that will get you help you get going. But yeah, you need to do it once. Creating the data depends, or the duration to create the data depends on your machine. For my old PC, I think it's about 14 years old right now on a Core i5. It took around 8 hours to complete. If you've got a modern machine running with the latest processors, maybe it's just an hour and it's done. Mostly it's just writing out data into CSV files. If you want to get really funky, you can also create updates and delete sets, so you can almost mimic a complete CRM system. When it's all done, you get a database schema. It's a normalized schema, and the funny thing is, the more columns you get, the more rows you get. So you can see bottom there's a nation and region table. Region has 3 columns and has 5 rows. Nation has 4 columns and has around 25 rows. And for every table you add with more columns, like supplier or parts supplier, you get more rows as well. So it's expanding both horizontally and vertically. When I created the stuff, and this screenshot only works when I'm presenting this on a cinema screen, you get a long list of files ranging from 394 bytes for the nation table, region table, to 75 gigabytes for the line item, which is the line items for all the orders. The best thing about this is that it's all bogus data. There's nothing privacy related or anything in it. It's just data you can use, you can share it. If you want to use some of my files, I could give you access to my storage account and go ahead, use it. It's free, it's nonsense data. It's a little quickie to get running, and it's very flexible. You can create really small data sets of just 500 megabytes to terabytes if your local computer can handle it. Your local storage essentially is the bottleneck for creating the data. All right, we've got our stuff, we've got our data, we know what to look for, so let's start testing. And let's start testing by ingesting and processing data. Now, there are a few ways to get data into Fabric. I'm still skipping the real-time ingestion options here, just like the third-party toolings that claim or can do the same. I'm just sticking with the basics you can get from Fabric. You can use a pipeline to get your data from your source and write into either a lakehouse or a warehouse. Same goes for notebooks and for Dataflow Gen 2. For notebook, you can only write to a lakehouse. Mostly the differences are a pipeline is, by and large, in my opinion, the best way just to move data. Just read it from a source, get it into a target. Notebooks and Dataflow Gen 2 have more options to model and join and do other cool stuff. But the main question in choosing your tooling, as shown here, whether you're using a pipeline, a notebook, or Dataflow Gen 2, is what's the best fit? In general, I'd like to say getting data from sources easiest with a pipeline. It's like copy paste, incremental stuff, simple. Use the pipeline. If you're going for APIs, notebooks already get a little bit ahead of this curve. But pipelines do have easy options with incremental loads as well. So there's the copy job, which will make incremental loads quite easy, stuff like that. In a notebook, you'd have to write it out. But let's just dig in.
Resta, there's a question if that's okay.
Yeah, sure.
When you say F64 equals 64 and 30 seconds equals 1920 capacity unit, what does that capacity unit mean exactly? Example, number of transactions, seconds per second, or what?
I was afraid this question would come up. So this 1920 is like the number that's being used to. No, let me try a different analogy. If you're coming from a SQL world, you know, like the query cost. This query will cost you 10,000, and it's a number. It's not a completely made up number. It comes from the back engine that says this number is related to, I need this much CPU, I need this much memory, and this much I/O. Altogether, it generates a number. The same goes for Fabric, where this number will tell you, I've got this much compute, I've got this much memory, and I've got this much I/O. There's stuff happening at the back when you're deploying a capacity. the larger your capacity is, the more CPUs you get. At the end of the slide, this presentation, I have a slide where you can see the differences between the different F capacities. The reason that they've boxed them in blocks of 30 seconds is so they can do this bursting and smoothing trickery, where you can borrow capacity from the future, which means you get extra CPU power for a short amount of time to get your process over the finish line. When you're learning about this for the first time, it is hard. It broke my mind a few times, and it's still hard to explain. So I hope this helps. If it doesn't, I'd say wait to the end of the session after I've shown those slides where I'm showing a few differences within the capacity units. If there's still questions, let's get into them at that point.
Yeah, we'll leave the questions to the end, will we?
About the capacities, yes. All the other questions, feel free to jump in.
Okay, I'll ask one more if that's okay, as there's a few coming in now. Is there any way to kill an operation in Fabric? Assume that you have a large semantic model and report user query consume a lot CPU.
There's no graceful way to kill rogue processes. What I do, and it's like using a sledgehammer to kill a mosquito, it's just pause the capacity, which means all the compute will disappear, all the running processes will be killed, but all the rogue processes are killed as well. So you can, it's not a gentle way to do it, but it's the best way to make sure runaway processes stop working. Yeah, you might be able to go into the monitor and see what's happening. At this moment, I can't recall if there's a cancel button there, but you should be able to find out who's running something. So if somebody is running a really hefty Power BI report, you should be able to see who it is and tell the person, please stop this process within Power BI. That's the gentle option. But if it's a rogue process, you can't find it, pause the capacity, and everything will stop working.
Perfect. Someone just added to the question before. You just said, okay, how will I know how much of that 1920 is being used right now?
That's $1 million question. The main issue, the main point of the thing we've run into testing the capacity metrics app is that it's always lagging. So you need to refresh the underlying semantic model, which is using import mode, and then refresh the report. But you're always running behind. So what we're hoping for is that at some point in time, Microsoft will give us access to live data, where we can immediately see, oh, there's a process going into bursting mode, is losing a lot of our capacity, we need to intervene. But right now, you're always lagging, to be honest.
Perfect, yeah. That's all the questions for now, anyways. We'll take the rest later on. Yeah.
Yep, cool. So using pipelines, it's like Azure Data Factory in a little bit of a new GUI. You can recognize it. It's quite safe, quite stable. So for my load testing, what I did was just create a pipeline where I'm reading my CSV files and just pushing them into my lakehouse in the files section. It's not really hard. There's no rocket science here. Settings all set to auto. And when I ran it on my F64 capacity, it took around 33 minutes. And when I ran it on my F2 capacity, it took 32 minutes, almost 33. So this one, it doesn't really matter if you're using an F2 or an F64 because you won't get the extra performance. Reason being, there's hardly any compute involved. This is just networking, the read capabilities of the source, the writing capabilities of the one lake. That's about it. It's did use capacity units to process the data. So my F2 was hit for about 73%. I did some testing on the F64 a few times in a row, and it took around 22% to try this one 10 times. So this is, if my highlighter comes to the right screen, this is where you can see my CUs for this block of 30 seconds. I've got 1920 available, and I used 438 in this background process. This is where you need to find out how much capacity am I using. So the thing is, whenever you're starting a new project, please try and start on the trial F64, which will give you a lot of capacity. And you can find out when you're running your processes, how much capacity am I using? How much capacity is my environment using? Because if this keeps under the 50%, for instance, you don't need an F64. You can use an F32 maybe. If it gets quite low, like this one, you can scale down even more. So using the F64 for your proof of concept or for your first stages in your project will give you an indication of how much capacity you need. Again, you can get into the time point and find out how much has been used, and recalculate if the numbers add up. So this was just pipeline ingesting data, but let's be honest, ingesting data is not everything we're going to do within Microsoft Fabric. We're gonna model the data prepared for our reports, etc. So let's go into notebooks, because what I found, and it's jumping a little bit ahead of all the conclusions, but notebooks are the most efficient way right now to play around with data. Remember, you need to know what you're doing. You need to code, so you need to have the knowledge how to create that code. So the first thing I did was create a number of notebooks to convert my CSV to Parquet files, which means I need to define my folder path, the table name I'm going to write it to, define the schema, which means just telling it what are the column names and what's the data type. Tell it I'm reading for a CSV file. Please drop all the malformed lines because they will be there. There's a weird separator. I'm going to write it into my Delta Parquet storage. And I want to save it to the tables because it's going to create a table for me. So when I use the F2 to process 120 million rows, it took about 2 minutes 28 seconds. Fine, it's not that much. When I went to the F64, which means I'm using 32 times more capacity, but I'm also paying 32 times more, times were down to 1 minute 13. So again, I'm going for 2 minutes 28 to 1 minute 13. So I'm halving the time. Halving the time will cost me 32 times more money. This is just one notebook, but I just want to make you aware how to do these calculations in your head, because you're going to use a lot of notebooks probably in parallel as well. So these calculations will be different, but singling one out, there's a difference. So when I'm going to do a notebook with more data, which was the line item, you know, the big one, same structure, it took 2 hours and 4 minutes to process my 4.2 billion rows. To be honest, I thought this is okay. I'm not paying that much money. I'm processing a lot of data. I'm not modifying anything. I'm just processing the data. All right, 2 hours, 4 minutes. So let's see what happened when I switched this one to the F64. 7 minutes, 46 seconds. Done. This is where the F64 comes into its own right. It needs a large amount of data. It needs a lot of rows to process. That's when you get the best from the F64. If you're running small data sets, don't even think about it. So you can see right here, and this is where stuff got interesting. On the F2, I used about 93% of my capacity on one notebook. which means if I was running a second notebook in parallel, there will be contention between resources and stuff might get nasty. When I was running the same notebook on the F64, something weird is happening, because you can see my total CU number went up to 293. So what Fabric was doing in the background, it saw that this was a lot of work, and it said, I'm not going to let you use all the capacity. I need to throttle your time, essentially. Slow down. I'm not going to burst you because it's not a process that I'm apparently willing to burst. But it'll take more time. On the F64, there was plenty of capacity. I mean, it was using 15%. So then it said, all right, go for it. Take all the CUs apparently that I need, which were almost 300. By this, you can also calculate, I've got 60 in my F2. Apparently, I need about 5 times more, which means either an F8 or an F16 would be a good match for this, this specific notebook. Again, you'll be running stuff in parallel.
Red, so someone just said how much capacity used for F8?
F8 is 240 capacity units for every 30 seconds.
Perfect, thank you.
All right, let's move on because you're asking great questions, which means I need to move on a little. So this is where I started to play around with data a little bit. So all I did in this one is take the orders table and add a few columns. And I used a function to create a year, a quarter, and a month column. And I also partitioned the data, which means I'm going to use more of my compute capacity. When I used the F2, it took 18 minutes and 7 seconds to process 773 million rows and a little bit more. On the F64, it took 8 minutes. More or less, yeah, maybe more or less the same. It's just that I was hoping the F64 would do more. So at that point, I thought, well, let's go big. Let's join 2 huge tables. So this is combining order and order lines, which will lead you to a huge data set. The F2 took 2 hours and 16 minutes, again, processing all the data, all the stuff. And the F64 did it in 14 minutes. This is where there was a lot of gain from the F64. Again, it needs to compute stuff, it needs to process stuff. This is where I will have fun. And you can see it took around 25%. And the funny thing was on the F2, it only took 25% of my capacity. So somewhere optimizations are done, the process is being smoothed out right now, and I can do other stuff as well. Again, whatever you do, keep a sharp eye on what's happening in your capacity metric set, because you need to know all this stuff to decide what you're going to need. Now, in the previous installments of my session, this was about it. But lately, Microsoft has introduced something new called the native execution engine. You can create workspace environments where you can choose, I want to run on this version of the Spark engine, and I can use for instance, the native execution engine. And I did a little test. So when I was running my customers table on the regular environment, it took 2 minutes 29 seconds, and with the native execution engine, still on the F2, it only took 1 minute 46. Well, you can read all the results right here. The general, the gist of it is native execution engine performs better without rewriting any line of code. It was just, all right, I'm going to run you against a different environment, and I get a performance improvement. What's the catch? Maybe not all the code will work. I don't know. I haven't tested all the functions, so there might be a catch that some code won't work. You need to find out that one for yourself, but it's absolutely worth testing. It won't cost you anything extra. It'll cost you less. So what it's using, it depends on the complexity, and don't forget to test things. So the Dataflow Gen 2 originated from Power BI. It's a low-code solution, and when you look at it, it can look something like this. I'm joining 2 tables to get some data, done. So you can see I've got a few applied steps. I've got my navigation, which is table 1. I've got a merge query and my second navigation where it's done. Boom, let's go. 2 hours later, failed. All right, why? I've exceeded my capacity limits. So I went into my capacity metrics app, found the time point and saw that this was running my overage. It was blowing up and it kept running for some time. Because for some reason, these data flows Gen 2 take a lot of extra capacity. Whereas my notebook was just done, F2, no problem, 2 hours. This one blew up massively. So this is where smoothing and bursting got into contention, and the net result was the capacity just stopped responding. At that point, I thought, well, let's walk away from the data flow Gen 2. But there's typing error, it should say data flow instead of pipeline. There's some kind of turbo button that was added, which means I can improve performance again without changing my code. In this case, I can allow the use of fast copy connectors, which means I can process my data much faster. So what I did was try and find out what works and what doesn't work. Without the fast copy option, my ingestion completely failed. With the fast copy, it succeeded. Not only did it succeed, I could also see a huge drop in capacity usage needed, because I could trace down how much it would need, which was around 394. Why the F64 failed was just a timeout issue. With the fast copy, it only took 78, which means my F2 still fails, but the F64 will succeed because it uses less capacity, but it also uses less time. Joining table, it's still not the best, but we're getting there. So it is improving. So whenever, if you have to use the data flow Gen 2, make sure you check out this fast copy option, because it might just help you succeed on in that area. But again, my advice would still be use it as little as possible. Use either the data pipelines or the notebooks. So use it with care. So then I tried, well, I've ingested my data, but what's data without a report? Now, I'm not a reporting designer. You could almost say I don't know what I'm doing, kind of, sort of. But I'll tell you this, if you're using a bad design, it will lead to very bad experiences. So I created a simple semantic model where I've got my fact table, and I've got a customer dimension with this, which is connected to a region, nation dimension with it, which is connected to a region dimension. Kind of sort of snowflakey. And when I did this, I couldn't load the data because I was loading way too much data. This was an issue with my design, and kind of sort of on purpose to find out what would happen. All right, so apparently there's a limitation on the number of rows, depending on the Power BI license as well, I think. So it said, well, you reached your capacity limits. All right, let me see the details. You've exceeded the limits. All right. So whenever you click on this stuff, sometimes the error messages aren't as helpful. So you need to take a look at your capacity metrics app again and look at this one, the overage graph. And you can see right here, this is where the issue started. 2000%, and this green line will show you how much is added, which is over 200% for every 30 seconds. The red line is the total, the percentage you see on the right, the 2000%. In the end, what you can see here is I went 25,000%, something like that. So what you can see here is that creating the overage did take some time. I think it was about an hour. The burn down here was 3 hours, even more. Yeah, it was around 3 hours, I think. So my capacity was bursting at a triple rate. So instead of using an F2, in this case, I was using kind of sort of an F6. I was close to using an F8 with the capacity until it errored out. And then it started to build up the overages, and it starts to build it up first, which means your capacity will be non-responsive, less responsive, throwing errors, stuff like that. And then it starts to burn down, which means you're going to pay back all the capacity you've been using in advance, meaning your fabric environment will become unresponsive, which is not all that good, especially if people are waiting for their reports. The question is, how can I increase this? Well, one of the ways you can increase or go to faster burn downs is add capacity units. So when I was experimenting with this, it was in a burn down session. You can see right here at 9:43 in the evening, it was expected to burn down in 7 minutes. Then I switched from the F2 to the F8, and all of a sudden, my expected minutes to burn down 30 seconds later were reduced from 7 minutes to 1 minute. Which means you can just throw money at the problem. The alternative is pause the capacity, wait a few seconds, restart it. What it does is will clear out all your burn down time that's still remaining, add it to your Azure bill, and when you restart the capacity, it will be at 0, if you will. So it will start fresh and you can start running all your processes again. It's not something I'd advise to do, pausing and restarting, but if everything is messy, it might get you through. So let's take a summary of all the stuff we've seen, a few things. Because this one is for me the most important. I like the notebooks because they're the most efficient ones, and you can try and find out the differences between the different capacities. So right here, I've compared the F2 with the F64, where at the bottom you can see that the F2 would take around 5 hours to process these this data flow, and the F64 would take around 65 minutes, which is all right. But early in the session, I told you also something about the native execution engine. So when we compare the native execution engine with the F64, you can see a small difference. Instead of using around 5 hours, it only takes around 3.5 hours. And it's not 5 times as slow, or the F64 isn't 5 times faster, it's only 3.2 times faster. Now, why am I reiterating this? First, you can see that the big tables and the join stuff, the F64 is still way faster. What you need to remember is that the F64 is 32 times more expensive than the F2, which is fair enough. You get a lot of resources. I'll get to that on the next slide. But this raises the question, how much money are you willing to spend for performance? Second thing is, these tests were done with everything serial, so notebook after notebook after notebook after notebook, or it was one notebook with cells that were run consecutively. In the real world, you're going to start running stuff in parallel. And then you can quickly see that the F2 will run out of breath because it doesn't have that much capacity to spare. You can see the capacity units on the right column, 43, 56, 82. 82 is already a little bit over the 60 you've got, but it will manage, but it will take more time. But if you're running everything together, so if you're running all the pipelines together, you're going to need around 180, little less than 180 capacity units, which is 3 times more than the F2 has to offer. So if you're going to run stuff in parallel, if you can, because if you're running star schemas. You can't do everything in parallel because you need to have your dimensions before you create your facts. If you run stuff in parallel, you need more capacity than the F2 can offer. If you're gonna develop with more than one developer, the F2 won't cut it. We've tried it. The F2 just runs out of breath. You need an F4 or an F8 to have a good developer experience. So what are the differences? Microsoft offers a nice overview of all the differences between going from F2 to F2048. I've only gone to the F64 to keep it readable for you. So you see the capacity units on the left compared to the Power BI SKUs. Remember the P licenses are no longer available. It's all Fabric license nowadays, but you can see what happens with the cores. So for Power BI, it will offer a quarter of a core, whatever that is. I don't know how they're going to split the core, but apparently they can. If you're using an F64, you get 8 Power BI V cores, which means your reports will probably perform. But more importantly, Fabric is mostly powered by Spark cores, which means you need cores to run your process on. And if you've got an F2, you got 4 cores. With an F4, you get 8. With an F8, you get 16, and so forth. Everything doubles. Just look at your own laptop. How many cores does your laptop have? 6, 12, maybe on hyperthreading. Maybe you've got a luxury room. You've got 8 cores and 16 in hyperthreading. It's your local laptop. It's meant to just serve you. And when you're using a reporting solution for a company, there probably will be multiple people getting into your data at the same time. Do you want to serve them on 4 or 8 cores? Maybe, maybe not. It just depends on how you're building your entire solution. Just keep in the back of your head, if you want a good experience, maybe you'll need to go F8. And F2 can do a lot of stuff. I've shown you it can do a lot of stuff, but it's all serial. It's all step by step by step by step. So you need to get a good grip on anything that the Fabric Capacity app is going to tell you. In the slide deck, I've included some resources for the TPCH dataset stuff. We can find the schema, but also how to create the executable. And that's the most important resource. All the other stuff, there's a lot of information online. I saw some session from this ESPC conference where you can learn a lot. There are many blogs out there telling you best practices, helping you out with all the questions and all the other things. So let me leave you with, first of all, thank you so much for attending, asking the questions during the session. I'm guessing there are a few waiting right now. And again, in the top left corner, QR code for my GitHub.
Yeah, there's a lot of questions in here. So thank you, Retta, for a great presentation. So now I can questions answers. The first question is, with a company who has bought into Fabric but at an F2 to explore, sounds like the cost of F2 is higher versus higher is time. Can we read that out again? Okay.
Yeah, I don't fully understand this.
Yeah, with a company who has bought into Fabric but at F2 to explore, sounds like the cost of F2 versus higher is time.
One thing you can let me know. I don't know who asked the question, but let me know if I'm misinterpreting the question. One thing you can do is you can always scale up and down. As long as you haven't put a reservation on the subscription where the capacity resides, you can always scale up and down without any additional cost. So if you find out an F2 isn't working, you can just scale up to an F4 and move from there. The other way around, if you've started out with an F32 and you find out, well, an F16 would do the job as well, just scale down. It's pay as you go. So you can play around with scaling and find out what works for you. But I hope that answers the question. If it doesn't, please let me know.
Perfect. And the next question is, Is the SQL endpoint sync delay related to the capacity CUs?
No, the endpoint delay is not related to the F capacity. It's just delayed, and I've got an opinion on that.
Perfect. So the next question there is, one thing we've noticed with the metrics app, when trying to use the date slicer, if you select anything, today's data gets removed. You can only see today's data if there's no filtering on that slicer.
I haven't seen that one. I would say if you can reproduce it, put it into the Fabric Ideas site, because they're using that as a kind of a bug list as well. And make sure to tag, you can tag me or any other Microsoft MVP data platform MVP, and we'll try and reproduce it and accelerate it with the program team, because it should not do that.
Perfect. So the next question there is there any inbuilt partitioning functionality available in Fabric?
Provisioning as in the Fabric capacity or something else?
Yeah, that's all.
Maybe the person who asked this question can elaborate a little bit.
Yeah, they've asked another question anyway. So in Microsoft Fabric notebooks, how can I read from and write to multiple lakehouses across different workspaces, given that only the default lakehouse is mounted? What are the best practices for standardizing data access paths across notebooks to ensure consistency in collaborative environments?
You can create or you can find the I'm not sure what it's called, but when you're opening a lakehouse, you can find the kind of sort of the one lake link to it, which will give you the name of the lakehouse and then the name of the table, and you can use that one over the different workspaces. So you can through that. If you're using that way of working, you can collaborate over multiple lakehouses and get data from different lakehouses. So what we in the design my company is using, we've got a workspace for every layer of the medallion architecture, if you will. We've got an ingestion layer or bronze layer where all the data lands, and then we've got a silver layer which has its own lakehouses in its own workspace. And we are using a link to the ingestion lakehouse to read the data, and it's just a link from the just link the lakehouse presents to you. So not the SQL endpoint, but there's another link available.
Perfect.
Send me a message if you want to learn more about that.
Yeah, amazing. So the next question is, how does the lakehouse behave compared to the eData warehouse according to capacity usage?
To the SQL data warehouse, I think they're meaning?
Yeah, they just said data warehouse.
Yeah.
Yeah.
So what I've seen is that the data warehouse is using more capacity because the backend is still the Delta Parquet stuff. So what the warehouse needs to do is translate all your SQL queries to PySpark in a way and make sure the data gets written out into Delta Parquet. It just eats capacity like mad. So again, my preference is Lakehouse because you've got a one-on-one link to your Delta Parquet, and you can. It's the easiest to tune, and the warehouse is harder to tune. Then again, if you're working in a company where there's a lot of SQL knowledge and not so much PySpark knowledge, it might be cheaper from a people perspective to use the warehouse. So that's a business balance in the end. A business
Perfect. Course. Yeah, that person just said thank you. The next question there is there any cost to pause and resume reserve capacities while throttling or highly consuming capacity?
When you're pausing a capacity that's been reserved, your reservation will keep on running, which means you'll still be paying for a capacity that's being paused. It'll get interesting when your capacity is overloaded. You pause it to remove that load and then resume it. From what I've understood from the licenses, you still need to pay the extra usage of your capacity because it's outside of the reservation you've made. So when it's going rogue, there will be an extra cost incurred when you pause it. But when you pause it without, if there's nothing extra running, yeah, you're just paying for capacity that's not running, which is kind of a waste maybe.
Perfect. That's all the time we have time for, but is it okay if they ask you a question directly through LinkedIn, Retsa,
Sure.
if that's okay?
Yep.
And
No
you
problem.
said your slides are through the QR code at the start of the presentation, wasn't it?
Yep.
Yeah, perfect. Just people are asking that as well. Yeah, so I think that's all the time for. So on behalf of the ESPC community, we'd like to extend a big thank you to you again, Retsa, for taking time out today to carry this webinar. Really appreciate it.
My pleasure. I loved it.
So that's the end of today's webinar. You can find this webinar and more at sharepointeurope.com/resource center. Thanks again for all of you joining us today, and I hope you join us again soon. Take care.
Bye-bye.